Right, fine. All right. Sunny, it's like they want to see you. I don't know your video. Can your video show? No, it can't show. It can. Huh? Ask to start video. Okay. Okay. We'll ask you to show. They just want to see you, Sunny. Okay.
Oh, okay.
Right.
I to put my hamster.
Come again. Hello.
Sorry, sir. Yes, I'm here.
Okay. Yes. Okay. All right. The girls they want to see you. Okay, but it's fine. All right. Let's.
I don't know if I feel comfortable with this for viewing pleasure. It doesn't seem like I just don't feel comfortable with it.
Okay. No, it's fine. It's fine. You don't have to. You don't have to. Okay.
Thank you,
It's
sir.
fine. Okay. Let's look at exercise. This is today's work. So I just want us to look at exercise 34. Right. So on exercise 34 is the one that I gave you last time. Right. So you are given there. Number one, diborane B2H6 was once considered for use as a rocket fuel. The combustion reaction for diborane is given there, B2H6 plus 3O2 to give you HbO2 plus H2O. That's what we have. Clear? Right. If we react 2,37 grams of diborane, how many grams of water would you expect to produce? All right. Okay. Yes. Mm. O2. Yeah. Where did they get there? The O. Is the formula for whatever product they get when these two burn. Is the hydrogen in the B and the O? No, it's just B. Remember, B is boron, H is hydrogen, O is oxygen. So here you get a bond where you've got boron. Yeah, there's an oxygen as well there. Yeah, okay. Right. So here, what are we gonna do? We're gonna look at this. I've written this in the other class, but I think I will continue with this. I don't know if you are not happy, then I'll have to redo this. Okay. Are you comfortable with this? No. You want, you want your own? Okay, fine. I'll have to redo this, so it's fine. Let me just do a new page. I can delete. When am I going to finish with this? Right. So we start. Right. Number one. Right. What are we given? You need to know what are we given? What am I looking for? So here from diborane, what am I given here? So I'm just going to write it here. From diborane, what am I given? I'm given mass. So I'm going to write mass given here is equal to 2,37. 2,37 grams. Right? Then how many grams of water? What am I looking for? I'm looking for water. I need to know what is the mass of water. This is what I'm looking for. All right. So how do I move from diborane to water? All right. I have to find the number of moles. Remember what we said. Every time you are given something, you must find the number of moles. All right. So from the information that is here, what is it that I can get here? All right. I need to find number of moles. So I need to look for number of moles. I need to look for number of moles. Right? So what can I get? I can get the molar mass for diborane. Molar mass for diborane is going to be B2H6. Molar mass B2H6. This is equal to your B. What is the molar mass for boron? B, it's what? 11, eh? 11 times 2 plus hydrogen, which is 1 times 6, which gives me how much? 28 grams per mole. So I get 28 grams per mole. Right. Now I've got mass, I've got molar mass. What can I get? I can get the number of moles, isn't it? So I'm going to do it here. Number of moles. This is number of moles for diborane, B2H6. Because you're going to have so many number of moles to calculate, please just specify which number of moles we're talking about. All right, so it's going to be equal to mass, small m, over capital M, mass over molar mass. Right, so my mass is 2,37 over 28. Right, what's your answer? 0,08 moles. Right, that's what you have. Now that we have the number of moles for diborane, now what do we do? Huh? We compare, we do the ratio. So you're gonna compare. To get mole, you do the mole ratio. Compare the ratios. Where do you get these ratios? You get them from the balanced equation. Right, so you go to your balanced equation. What is the ratio? We are comparing diborane, which is B2H6, is to what are we looking for? Water. So we're comparing diborane to water. What is the ratio here? Borane here in front here, the coefficient here is 1, and the coefficient for water is 2. So what is the ratio? 1:2. All right. Then you've got your moles that you got here is 0,08 is 2. That's what you're looking for here. All right. What do you do? 1:2. So whatever is 1 here, you double here, isn't it? So basically, what are you doing? It's like you are multiplying 0,8 by 2, and you are dividing by 1. So here you multiply across, and here you divide. So if I've got 2:3, I'm going to multiply here by 3, divide by 2. If I've got 4:1, I'm going to multiply by 1, divide by 4. Always. Yeah. All right. So here I'm going to divide. So number of moles of water. Number of moles of water is equal to, I'm going to have half or 1/2 multiplied by 0,08. Right, my answer, what do I get? 0, sorry, am I right here? No, I'm wrong here. No? Times 2, I'm wrong here. It's 2/1, yeah. 2/1, okay. All right, so it's going to be 2/1 times 0,08. Your answer becomes 0,16 moles. Right, that's what I have. Now I've got the number of moles for water. So here I know I've got number of moles here. The number of moles I know I have 0,16. Right, what else do I know here? I can find the molar mass. Molar mass for who? For water, because I'm talking about water. I'm not going to use that 2. That 2, I only use it when I do ratio. So please, when you do molar mass, you're not going to say 18 times 2, because the molar mass for water is 18. You're not going to say 18 times 2. You don't use that 2 to find molar mass. Only you need for H2O, not 2H2O. Right? So your molar mass is going to be 18 grams per mole from the periodic table. Hydrogen is 1 times 2, and oxygen is 16. Now I've got number of moles, I've got mass, molar mass, I can find the mass. What am I going to say? I'm going to say number of moles is equal to mass over molar mass. Which number of moles are we talking about for water? Don't take the one for diborane. All right. So the molar, the number of moles becomes 0.16 is equal to the mass, which is what I'm looking for, over molar mass. The molar mass is 18. Right, then I make mass the subject of the formula. So I'm going to have, this is an 18 here. Right, so I'm going to have 0.16 multiplied by 18, cross multiplication. Right, my answer, 2,88 grams. 2,88 grams. 2,88 grams. Is this correct? How come the other class, they got 3 commas something? Just double check. This is 18, yeah? 0.16 multiplied by 18. Huh? Okay. Right. Let's check. 18 is the, sorry, it's not 80, it's 18 from water. Hydrogen is 1 times 2 plus 16, which is 18. Molar mass for water. Huh? Come again. Are you talking? Okay. Right, how do you mark this? When you mark, you're going to start here, mass formula, 1 mark. Substitution here, another mark. We're not going to give a mark for the answer. We're going to give a mark for the ratio. To do the ratio to get 0.16, you get a mark. Then we come to this side here. You're repeating this formula here, so I'm not going to give a mark. We're going to get for substitution. Then we're going to get for the final answer. To make it 5 marks. It's 1 mark formula, substitution, ratio, where you're getting the mole ratio, substituting into the same equation that I've awarded marks here, and 1 mark for the final answer. Clear? Right.
So,
Yes.
So we can't round it off.
Like to the nearest whole number.
Yeah.
No. Always your answers must be correct to 2 decimal places. That's an instruction for your most of the exams. You only round it off to the nearest whole number unless if the question specifies to say round off your answer to final to whole number or 3 decimal places or whatever. But on default, it's supposed to be 2 decimal places.
Okay.
Yeah. Okay. Any other question? Right, so this is the stoichiometry that we're talking about. So you do the number of moles of what you are given, then you do the mole ratio to get the moles for the substance that you want to find. Then after that, you apply the formula. Right, if there are no questions, let's move on to number 2. The second one. All right. Right, there's number 2. I'll have to delete this so that you understand what I did here. Yes. Okay. Right. We start. Right. We start with the first one. Sodium azide is a commonly used compound in airbags. When triggered, it is the following reaction. Right. We all know what is an airbag. An airbag, it's a bag that is empty. The bag that is empty, yeah. Basically, when a car is involved in an accident, then there's a sensor that triggers this particular reaction here. So that bag contains, initially contains no air. It contains this substance here. So when that reaction is triggered, then this substance is going to decompose and produce nitrogen. And that nitrogen gas that is produced is the one that fills the airbag. Are we together? Right. So you find sometimes a car is involved in an accident, the sensor does not work, and this reaction does not take place. So the airbag does not work. Yeah. Right. So you always need to check whether this is going to be happening here. So this is what is happening here. It's a decomposition reaction, as you can see. So we are told if 23.4 grams of sodium azide is used, how many moles of nitrogen would we expect to produce? What volume would this nitrogen gas occupy at STP? So there are 2 questions here. How many moles? Then the next one, what volume? And we are talking about nitrogen gas. And we are given the condition at STP. All right, so let's check what is given. What is given here about sodium azide is what we are given. What are we given? We are given the mass. So we've got M, which is 23.4 grams. Right? What else are we given? That's all we are given. What are we required to find? We are required to find nitrogen. What is it that we need from nitrogen? From nitrogen, what do we need? We need number of moles, N. We need to find number of moles for nitrogen. What else? We need volume. We need to find the volume. Clear? Right. Now, from what we are given, what is it that we can find or will help us to get here? Number 1, we know we can find the molar mass for sodium azide. We can find the molar mass for sodium azide. What is the molar mass for sodium azide? It's going to be sodium here, which is 23, isn't it? Plus nitrogen, which is 14. 14 times 3, it's how much? 42. 42 plus 23 gives you 65. So you're going to get 65 here. You don't use that too. For molar mass, you don't use that. Right, so we've got 65 grams per mole. If you are not comfortable with this, please let me know so that I can show you how you get your 65 grams per mole. Right? Okay. Then we have got mass, we have got molar mass. What are we looking for? We need number of moles. So we can find the number of moles. Right, number of moles. For which one? This is for sodium azide. Sodium azide. You leave it out. Right, they're asking about these 2 here. The coefficient, you don't use it. Well, this is for balancing. It's not, what can we say? We don't use it when you find the molar mass. Okay? Right, then you're gonna say mass over molar mass. Right, then your mass, what is your mass? It's 23,4 divide by 65. What's your answer? 0.36 moles. Right, now we've got the moles for sodium iodide. Now we want to move to nitrogen. But before we get to nitrogen, we need to compare so that we find the corresponding moles. So we're gonna compare. Right, so in the comparison to get the mole ratio, what we're gonna do, we're comparing sodium iodide, which is Na3, NaN3 is to N2. NaN3 is to N2. Now we check what is our ratio. Sodium iodide, the coefficient there, how much is it? 2. That's when we use that 2 now. 2 is to nitrogen. What is the coefficient here? 3. 2 is to 3. Then we can get the number of moles that we have, 0.36. Yes, Zinedine.
Sorry to interrupt, but sir, I just wanted to ask, that number in front, the coefficient, is that the number of moles in each of
Yes, that's the number of moles.
the ratios?
Yes, that's
Okay,
the number of
thanks.
moles. Yes. So basically here you've got 2 moles of sodium iodide. When it decomposes, it's going to give 2 moles of sodium and 3 moles of nitrogen. Yes.
Okay, thanks, sir.
Right, then we come to this. We need to evaluate this using that ratio. We need the number of moles of nitrogen from the sodium iodide moles. So what are we going to do? We're going to multiply by 3 and we divide by 2. So you multiply and you divide. So number of moles of nitrogen is going to be equal to, right, we're going to have our 3 over 2. Basically, it's 3 over 2 times 0.36. So it's 3 over 2 times 0.36. This will be over 1. All right, your answer? What's your answer? 0.54. Right, so you get your 0.54 moles. Now we have the moles for sodium, for nitrogen, sorry.
So,
Yes.
so is it okay if we just if we first divided 0.36 by 2 to find the value of 1 mole, then multiply that by 3?
Yes, it's fine. It's fine.
Okay. Okay.
So, right. So we've answered the first part of the question. This was the first question here. Number of moles of nitrogen. So it's 0.54. All right. Then we move on to the second part of the question. So now number of moles we have. So we can write here our number of moles we now know is 0.54. Volume. Now there's a third information that we have, which is molar volume. Where do we get this from? We get this from STP. At STP, standard temperature and pressure, what is our molar volume? Our molar volume is 22.4. So this is known, this is a constant, 22.4 cubic decimeters. Right, now we've got number of moles, we've got Vm, and we're looking for volume. What equation are we going to use? What equation? N Right, number of moles of nitrogen is equal to V over molar volume. We substitute, our number of moles becomes 0.54. No longer using 0.36. This was just a way of helping us to find 0.54. Right, so use 0.54 is equal to volume over molar volume. Your molar volume, what is it? 22.4. Right, we make V the subject of the formula. V is equal to, you cross multiply, it's going to be 0.54 multiplied by 22.4. Your answer, what's your answer? 12.096. We round it off to 2 decimal places, becomes 12.10 to 2 decimal places. And your answer becomes in cubic decimeters. That's your final answer. Right, how do you mark this? Right, the first mark is formula, mass over molar mass. Second mark, substitution. Third mark, the ratio, using that ratio there. Fourth mark, because this was a standalone question, you're going to get a mark for the 0.54. All right, second part of the question, our formula is changed. It's no longer the same formula, so we give you a mark here. Substituting this, and your final answer, 12.10. So you get 7 marks for this question here. Two, 4, 6. So you get 7 marks. You get 7 marks. Any questions? Right. So please, when you answer these questions here, you go step by step. Check what you're given. Check where you're going. In between, to move from one substance to another, you have to via mole ratio from the balanced equation. Right. We move on to the last. Yes. Let's go up. Okay. This is number 2. Which one do you want? Huh? You want it? That's fine. Okay. I move on to the next one. The last one. The one for photosynthesis. All right. What I'm going to do, let me just delete this. Just delete this. All right. Just remove the balancing. I'm writing with the mouse, so it takes time. That one, I left it today. I decided to use this. Right. It will be a dual role. It can be a projector. It can also be a thing, camera. It can also be a camera. Yeah. Okay. All right. Fine. So the first question, let's look at this. It says photosynthesis is a chemical reaction that is vital to the existence of life on Earth. Okay, guys. During photosynthesis, plants and bacteria convert carbon dioxide gas, liquid water, and light into glucose and oxygen gas. Write down the equation for the photosynthesis reaction. So what we have, the bacteria converts carbon dioxide and liquid water. So your first reactant there for A is going to be carbon dioxide. So you've got your CO2. plus your water, H2O. Sunlight is your energy, because this reaction is an endothermic reaction, so energy must be added. All right, to give you sugar or glucose, which is C6H12O6 plus O2. O2, that's your oxygen. All right, so you're going to get a mark here, 2 marks basically. You get a mark for writing the correct formula for CO2 and H2O. 1 mark for the correct formulas of the reactants, and 1 mark for the correct formulas of the products. So 2 marks for A. Why do you have a problem with my coffee? They say if your coffee is not productive, then it's not. But if it is a dry cough, then you must be worried. Right. Okay. Fine. And as long as you don't have a fever, then it must be something else. Yeah. Wait. If it's there, it's gonna come. So don't rush. Okay. Right. Okay. Right. Fine. So we have A. Sorry about that. We got cut off our network today. It's a bit slow. Right. Then let's balance this. Want to balance this? How do you balance? You look at carbon here, it's 1. Carbon here is 6. Right. So your carbon is not balanced. So we're gonna put a 6 here to balance the carbon. So the carbons are now balanced. Right. Oxygen is a standalone here. So normally oxygen must be the last one, because that one you can always play around to match whatever is here. So before I look at oxygen, I look at hydrogen. Hydrogen this side 2, and hydrogen here 12. So how do I make the 2 to become 12? I put 6 here. Right. So hydrogen is fine. Now I go to the oxygen. Oxygen here, 6 times 2, which is 12 plus 6 here, because this 6 is a coefficient, it affects that oxygen. So it's going to be 18. Right, I come to this oxygen here. There's oxygen here, 6, and I've got 2. So here, so far, I've got 8. But I'm not going to play around with this because it's going to tamper with the carbon that are already balanced. So I come to this one here. So I have already 6. So I put a 6 here to make it 12 plus 6, then becomes 18. That's how you balance that. Then you get 1 mark for balancing. 1 mark for balancing. So for B, you're going to get a 1 mark for balancing. 6, 6, 1, 6. So if the ratio is 6 is to 6, is to 1 is to 6. Clear? Right. Then we go to C. Right, on C, what do I have? C says if 3 moles of carbon dioxide are used up in photosynthesis reaction, what mass of glucose will be produced? What mass of glucose will be produced? Right. So what do I have? I've got carbon dioxide. So here, carbon dioxide. What do I have? Already, I've got 3 moles. Number of moles I have. I've got 3 moles already, isn't it? Right. Then after that, what do I do? There's nothing else that I'm going to do. Already I've got the moles. Are we together? So I've skipped, I'm 1 step ahead. So I just move on to the comparison now, because I want to find sugar or the glucose, mass of glucose, right? So the question wants me to come here, where I must find the mass of glucose. So I need mass of glucose here. That's what I'm looking for. In between, I have to do the mole ratio. So let me do the ratio. So here I compare for the ratio. Right, what am I going to compare? I'm going to compare carbon dioxide, CO2. CO2 is to sugar, which is C6, H12, O6. I check from my ratio. What is the ratio? 6. 6 is to 1. Because the coefficient here is 1. So 6 is to 1. Now, if I've got 3 moles here, how much do I get here? What do I do here? I multiply by 1, divide by 6. So number of moles of sugar is going to be C6H12 O6 is equal to my 3 times 1 divided by 6. Right, my answer gives me half, which is 0.5. Right, so I've got number of moles for the sugar. Now here I can write here, I've got number of moles here, which is 0.5. Right, I'm looking for mass. The formula that connects mass is number of moles is mass over molar mass. So I can find molar mass. The molar mass for sugar is going to be carbon is 12 times 6, right? Plus hydrogen, which is 1 times 2, plus oxygen, which is 16 times 6. I think you get 180. 180 grams per mole. It's a 12 times 6 plus 1 times 2 plus 16 times 6. Huh? 1 times 12, yeah. It's 12 times 6, 1 times 12, and 16 times 6. Are you getting 180? Right. Now I've got mass. I'm looking for mass. I have number of moles and molar mass. So I'm going to do N is equal to mass over molar mass. Then I simplify. Number of moles I know is 0.5 is equal to mass over molar mass, which is 180. Then I make mass the subject of the formula. Right, I just need to separate this. Right, my mass is equal to half of 180. Half of 180 is 90. Right, so my final answer here becomes 90 grams. Please, if you just write 90, we're gonna penalize you. You must write 90 grams. The units must be correct. If the units are wrong, you lose that final mark for the answer. Right, let's check. How do you mark this? 1 mark for mole ratio. Finding the answer here, mole ratio, you get a mark. 1 mark for formula, 1 mark for substitution, and 1 mark for the answer. Right, so this one is going to be 4 marks because there's one step that we skipped here, or we didn't do because we already had moles. So you're not going to get that. That's why the marks are few. Clear? Right, so you get a mark for the ratio, formula, substitution, answer. So for this question here, you're going to have